Okay, Algebra 2. Today should be the 17th. We're finishing up Unit 4. So I put 11 through 13, but this is actually lessons 6, 7, and then I think 11 and 12. 6, 7, 11, and 12. Let's see what we got here. So it's mostly applications of exponential and log, and so we got our formulas. I call this the basic growth and decay formula. That's how we start. That's how much we're starting with, A0. Here's our rate, which has got to be a decimal number and change percents to decimals, and then T is time. This is the same formula, but compound. So I might do N might be months. So N would be 12. Or N might be quarterly. And it'd be 4. Those are the two typical ones. And then we got our PERT formula, where E is a special number, and R is the rate, T is time, and P, we just use P instead of A0 to stand for the principal amount, the starting amount. So there's still the start, the time, the rate. It's just got to use that E button on your calculator, which, you know, right here. There's the E button right above the natural log. So a couple things happening here. That natural log, in fact, our first question deals with the natural log, which is like any other log. So the three laws of logs still apply. And I'm going to say, hey, division is going to turn into subtraction. So I'm going to say, hey, the natural log, the square root of E minus the natural log of y cubed. It's a cube, right? Yeah. All right, and then I'm going to say, hey, that's really the natural log of e to the half power. And now I'm going to use my power rule. I'm going to move those numbers in front. So I'm going to get 1/2 natural log e minus 3 natural log y. So I'm looking for this answer. And again, this is one of those Kirk's questions. He kind of hides it, kind of disguises it. If we got a common denominator, you'd see, I'm trying to think. Oh, wait, one more thing. Natural log of e. What is natural log of e? Those are opposites of each other. They're going to cancel each other out. So we're going to get 1/2 3 natural log y. So I'm looking for this answer. 1/2 3 natural log y. All right, so where's he got it hidden here? Right here. There's the 1/2, and then 6/2 becomes 3 natural log y. So there it is, choice 2. Got to look a little bit carefully. All right, so just keep in mind that the natural log of x is the opposite of e to the x. Opposites. They're opposites of each other. All right. So now we're going to start using these formulas I had at the top of the paper. Population's increasing, constant rate, 2.4%. Be careful. You're going to change that to 0.024. Right? Got to move that decimal point over 2 places. What percent will increase in 10 years? 10 years. Okay. Population's increasing. So we want to know what's going to increase in 10 years. So there's that 1 that goes here. So this is 1 year. How do I get to 10 years? Okay. Typical mistake is somebody multiplies by 10 and they would pick choice 1, which is wrong. What you got to do is take this 1.024, raise it to the 10th power. It has exponents, involves exponents. So definitely need your calculator for a lot of these questions. 1.024 raised to the 10th power. So I'm getting 1.2676 goes on. So what's my percent increase? About 27, 26. If you round it off, you'd say 26.8%. Right, move that decimal point back, 26.8%, which is choice 2. Okay. If places $650 in a savings account and it earns 2.5% yearly interest, compounded monthly though, compounded monthly. So now I'm using this kind of, I think, the most complicated formula. I'm going to use that formula right there. So A of T. So she's starting with $650. 1 plus the rate is not, don't put 2.5 there, it's 0.024. 5. Compounded monthly, though. Divide by 12. And up here I got to multiply by 12. 12 times what? After 4 years. Well, that's 48 months. See that? 12 times 4 gives you 48 months. How much money would you have? Just type that in the calculator. 650. Raised to the 12 times 4. So I'll put that in parentheses, 12 times 4. All right. I'm getting $718.29. There it is, choice 3. All right, sorry for the typing here. Maybe I'll retype this when you guys get it. But all right, I got 4 to the x equals 20. I can't get a common base. I can't use that trick that we did in a previous lesson of getting the common base. So what do I do now? I'm going to take the common log, not the common base, the common log of both sides. Why? So I can get this x in front on the ground here. All right, and then I divide by the log of 4. And whatever that is on my calculator, the log 20 divided by log 4. 2.16 something something. It says round to the hundredths, so I'm going to say x is 2.16. So if I took 4 raised to the 2.16, I'll show you. 4 raised to the 2.16, what am I going to get? Not exactly 20 because we rounded, but close to 20. All right. This next one, I can barely read it. And I got to retype that for you guys. 1/2 raised to the something. You know what? I can't read it. We're gonna skip that one. This one I can read. This has e, right? So first thing I'm going to do is say this is e to the x raised to the half power. That's what square root means. Up to you, but I'm just going to say this is e to the 1/2 x power to a power equals 60. Now instead of doing the common log, I'm going to do the natural log. Remember, natural log is the opposite of e. So I'm going to take the natural log of both sides. These cancel. I get 1/2 x equals natural log of 60, and then if I multiply by 2, I'll be done. So natural log of 60 times 2. Natural log 60 multiplied by 2. 8.19. 8.19. Okay. Now don't worry about this one. I think on your work, there's only 2 of these to do also. Yeah, you only have 2. All right, number 5. We got $10,000, and we wish, invested 8% interest per year. We're not going to put any more money in or take anything out. How much is left after 7 years? This is the simple question. We're going to use the simple formula. How do I know it's the simple one? It doesn't say continuous. This is when you have continuous. This is when you got monthly or quarterly or something tricky like that. This is the basic formula. So this is pretty basic. $10,000. The rate, I'm going to change that to 0.08. That's 8%. And after 7 years, how much money do I have? That's it. Put it in your calculator. 1.08 raised to the 7th power. $17,138. $17,138, and don't cheat me, 24 cents. All right. I'm going to keep using these formulas on the next page. How long will it take for 2,500 to become 4,500 if we invested at 7% compounded quarterly? Now, this is going to be our toughest problem, I think. I don't know, we got the more complicated formula. All right, we're starting with 2,500. I got the rate of 7%, compounded quarterly every 4 times a year. 4 times, how long will it take? I don't know. T, I don't know what T is, but I want to get to 4,500. I got the output. I'm looking for the input. Okay, got to work backwards. Step 1, let's get rid of this. This is multiplication, so I got to divide by 2,500. I get a lot of people subtracting, which would be wrong. All right, lop off those zeros. What's 45 divided by 25? Probably not nice. 1.8. 1 plus 0.07 divided by 4 4t. All right. You might want to take this and just change it to a regular. I don't think I'm going to do that. 0.07 divided by 4. Probably not coming out nice. 10175. And if you're saying I'm stuck, you got to remember to bring out the gun, the big gun here. We're going to take the log, both sides. The common log. Why? It doesn't have E in it, so I would use the common log. That's going to get this in front. So log 1.8 equals 4t. Log 1.0175. I'm trying to get t by itself. Divide by 4 and divide by this log. So t is by itself, and over here I'm going to get the answer. I put that in my calculator. Log 1.8 divided by parentheses 4 and the log 1.0175. 8 point, what are we supposed to round to? Nearest tenth. I'm going to say 8.5 years. That's how long it's going to take. 8.5 years. All right. This one's actually easier. It says continuously. Continuously. Why? Why is this going to be easier? Because it's the PERT formula. And the PERT formula is pretty easy. Got $10,000. E is a button on my calculator. The rate, 5%. And after 3 years, that's it. Plug it in, go. $10,000. Get the E button. 0.05 times 3. So I'm going to have $11,618.34. How long is it going to take for this money to double? Well, I started with 10,000. I want to get to 20,000. E, 0.05, but I don't know what the time is, okay? So just like that previous one, this is multiplication. What do you got to do? Start by dividing. I'm going to get 2 equals E 0.05t. Now this time I want to get rid of E. So instead of doing the common log, I'm going to do the natural log. Everybody see the difference here? Natural log is going to work a lot easier because these are going to cancel. So I'm just going to get natural log of 2 is equal to 0.05t. And then if I divide by 0.05, I'll be done. So whatever that comes out to be in my calculator. Natural log 2 divided by 0.05. 13.86, it says to the nearest year. So I'll put 13. 13.9 years. If we follow directions, I would say 14 years. Nearest year, 14 years. All right, tricky one, decreasing 10%. Talked about this during the year. If you're decreasing 10%, decreasing 10% means you're keeping 90%. It's like you go in the store, yeah, you're saving 10%, you're going to pay 90%. All right, so it's decreasing 10% means I'm keeping 90%. each minute, find to the nearest tenth how much it will decrease over 15 minutes. So we got to change this to a decimal number and raise it to the, I'm going from 1 minute, this is 1 minute, up to 15 minutes. Raise it to the 15th power. So 0.9 raised to the 15th power. I'm getting 0.20589. 0.20589. Now be careful, that's not the answer. This is what I'm keeping. What did I lose? So I got to subtract that. 1 minus that answer. So I lost. This is what I kept. So I lost 0.794. 0.794 keeps on going, which is 79.4% was lost. Okay. So if you keep losing 10% every minute, after 15 minutes, you've lost almost 80%. Okay. Tricky question because it's decreasing, not increasing. All right. A house has a value of $180,000 in 2012 and increases by 3.5% annually. What was it worth in 2020? So I'm going from 2012 to 2020. That's 8 years. There's my time. This is that basic formula. Because I'm not doing monthly, quarterly, continuously. So it's just the starting amount, 180,000. I'm increasing. Again, be careful. 0.035. And how much time went by? 8 years went by. So 8 years later, what is this house worth? 1 plus 0.035 raised to the 8th power. So 8 years later, and it says round to the nearest hundred, not hundredths, 100. So 237,000, and then be 0. 237, and then 000, because I'm rounding to the nearest $100. Now, if that was, if that was 125, then I'd round it to 100. If that was 175, I'd say 200. I'm just rounding that to the hundreds place. Okay. Assuming we continue to grow 3.5% each year, how long will it take to double, to get up to, if I started at 180, I'm going to get up to 360,000. So again, I want to double my money. Very common concept. It's the same as the last problem, except I don't know what T is, but I know the output. Got the output here. All right. So how long is it going to take? I got to work backwards. So third time, I first got to divide. I could do this in my head. That's going to be 2. 1.035 to the T. How am I going to solve this? Take the common log, both sides. Okay, common log. It says using algebra. I'm doing this algebraically, so this is algebra. T log 1.035 log of 2 divide. Let's see. I was going to try and guess maybe 40 years for it to double. Oh, that should be a log. The log. 1 point divided by the log 1.035. So it's going to take 20 years. Only about 20 years, according to this. 20, what does it say? Round to the nearest tenth of a year. 20.1 years. 20.1 years. So if you bought the house back in 2012, so in 2032, you would expect, hey, I'm going to double. That's assuming everything stays constant, which doesn't always happen. All right. Sorry, this was kind of a little bit longer than most. It was a little tougher than most. Go back, review it, do what you got to do to make sure you understand it, and then answer the similar questions on the independent work. All right. Stay safe out there.